finally I can start class. All right. Right, so while we were waiting for all this to get done, this is what I had you working on. Compare yours with whatever I get for mine. I said the easiest way to do these things is to allow first x to equal 0. Then when x was equal to 0, y was equal to -3. Did you all get that? Did you understand how those numbers are gotten?
Yeah, but question, so they all have to equal to 18, whatever you want.
That's right. So what I'm doing here is I'm replacing x with 0. Can you imagine that in your head?
Right.
Cover up the 3x because it's zeroed out. If you're just solving -6y equals 18, that's where you get the -3 from. Next, I'm going to allow y to equal 0. So you could cover it up and act like it's not even there, right? If you do that, what do you get for x? 6.
Well, what other numbers would you use to multiply?
I wouldn't pick any other numbers besides zeros, but you may be forced to, depending on the situation. Let me go ahead and get this. Let's get these, then we'll talk about those, the other points that you mentioned. 0, -3, you should have had to go down 3 spots for that. Did you guys get your point down here for 0, -3? Then 6, 0 was over on the x-axis. That's the x-intercept. And then I need to connect those 2 dots with a line. So let me get my line drawer. Now, if you've seen this enough times, you see that this is not the easiest thing for me to do. It would be easier if I could just draw the thing using rulers like you have, but watch it, see this, it doesn't want to stick where I want it. But anyways, let me pull it farther and try to do this as accurately as I can. Here's what you were talking about, the other points on here. Let's take a look at when x is equal to 1. Can you tell me, roughly speaking, what the y value is? So when you get 1 on this here, I put a dot on there. Can you tell me what the y value is of that? It's not, no, it's not, no, it isn't. That's -3. 1, 2, 3. It's somewhere between 2 and 3, isn't it? Whatever, you can't say for sure unless you work it out. What is it actually? Well, look, I'm going to allow x to be equal to 1 because I know that's what x equals. What's the y value? We're going to replace x with 1. So if I put 1 in for x, this is the equation I get. Three times 1 is 3, so this leads me to the equation -6y equals -15. Subtract the 3. If I divide by -6, I don't know how that. If I divide by -6, this may be hard for you to see. Well, y, when I divide by -6, will equal -15 over 6. which is the same as -2. Does that look like it could have been 2.5? I guess. You've been lucky that didn't work out. But if I were trying to put in 2 for y, negative, let's see, try negative, you can't. If I try to do -2 for y, nothing there, is there? Until you get over here. And then if I luck out, doesn't it look like it could be like x could be 2, but y could be -2? Let's see if that's true. So I'm gonna try when x is 2, I'm gonna plug it in the number. So the point will be here on the line. Do you think it's exactly going to be right? Let's see. So when x was 2, this is getting way complicated. You would have 3 times 2 minus 6y equal 18. Right. Now that stuff there, that stuff right there is just 6. So I get -6y equals 12. And then when I divide by -6. See that? The thing is, the zeros are always going to be the easiest ones. But they may not always work because you can get a fractional answer sometimes. Like this, you don't want to graph things like that. The only things you want to graph are stuff like these where you get whole numbers because you can't trust. I mean, when you guys look at that, you can't trust that was 2.5. You can't trust what you see. Only with this is where you get the real accuracy. So anyways, all you have to do is graph the 2 intercepts when that's possible. Okay. Are we good? Everybody good? Okay. All right, I'm gonna give you one to try another one to graph. The rulers I had it out loud, you can't keep them. The reason I'm doing that is because I want you to be rigorous to what you do. I won't give you credit on a test if you don't use a straight edge. Did you guys get these two numbers, 2 points? Good, you guys did these? And now let's go ahead and put them on. To get zero negative, I hope I have enough space, 1, 2, 3, 4, 5, 6, 7, 8. I remember what I was doing to make this look good, because I hate the idea of the horribly ugly dots that I put on the screen. It makes my beautiful graph look so bad. So what did I do in those cases? What I did is this. All right, 0, -8 goes down 1, 2, 3, 4, 5, 6, 7, 8. I'm gonna put that dot down there. I think, in fact, that's too bad. That might be just right. 1, 2, 3, 6, 7. Put my dot there. Now I've got that one. Now the other one was 6, 0, so it's going to be 1, 2, 3, 4, 5, 6. So I got my point here. Do you guys see where I got my dots? They're small, but did you see them? Now let me connect them with a line. So the reason why I like the small dots is it allows me to be much more accurate. Now that's a good looking graph, huh? Now what we're going to do today is going to be related to what we just did. I want you to look at that line. Have you seen anything? Just look at the line itself. If you start where the beginning of the line looks like it starts, so you guys realize these are never stops. Often tend to get better. So, if you have you ever seen anything like this on the highway? There. I'll draw a picture, and I know you've seen it. You've never seen signs on the highway like that? They're mostly for truckers because if a truck gets out of control, they can burn through those brakes and just notice they stop when they hit something. If what's that right? The steeper it is, you know, if you've driven behind one of these things, you know they're going to go slow, especially really steep things. You're probably going to go around them because they're too slow. So the steeper it is, has meaning. They're not, this doesn't really scare them. I guess the worst thing that can happen here is that they just fall out somewhere on the thing. The worst case is when they're going down. So you've seen these things before. They'll usually give you some sort of a grade here. They'll tell you what percentage it is. I'm not sure anybody needs all that. But you look at that, I know it looks like a bottle on wheels. But when you see that, you're like, okay, I know it's going to get steep, and I'm you know, on the lookout to make sure I don't lose control. You'd probably be like, oh, that'd be fine. Would you drive on a road like this? Suppose this now is the Coke bottles. You drive on a road with that kind of steepness? Probably not. Steepness has definitely meaning to us. It's pretty close to sheer rock face, isn't it? The slope tells us actually what direction we're headed in as well. I don't know if you do this, but knowing how much he's angled also tells us where the line is. So instead of doing what we were doing where we put in those points, we're going to instead study the slope of them. Much more powerful way. We'll be able to graph almost by sight. So slope is what the topic is for today. That is 4.4. Right, in that previous problem, what was it, negative 4x? What was that thing, negative 4x? Plus 3 log b. Let me grab that graph again, take a look at it, and tell you how we define this thing. This guy right here, it's pretty steep looking line. How do I determine how steep, or what is the definition of steepness? The steepness of a line is determined by how far it goes up versus over. If it goes more up than over, then it's steep. If it goes over and goes up, that's not so bad. What we do is probably the best thing to do is start down here. Let me use this as a point and kind of draw myself a right triangle. You guys ever see this? I don't care about that part of it. What I'm more interested in is how far this is. So that one, starting at x equals 0, it got to here. So that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this spot here is when x is equal to 12. So the length of this base is 12 units. Very good. How tall is the thing? So now, figure out how tall it is. I have to go from the bottom to the top. So starting down here, I don't care about the numbers, just tell me how many spaces I go from the bottom one to the top one. So I'll start down here. And I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We went up 16 versus 12 over. What we use for the slope is this. You're going to love this letter if you've not seen it before. The letter M is for slope. So you'll remember it. So we define it as the amount of y divided by the amount of x. In other words, I can simplify this if I want, or take out a 4. Now check it out. If I start at the bottom point, start down here, from that point, go up 4 units. 1, 2, 3, 4. Now go to the right 3 units. There you are, right on there. So the steepness is 4/3. That's how we say the line is steep. That's how we just label its steepness. So it's all rise versus run. Have you heard that before? M, the famous letter M, rise divided by run. How much it goes up divided by how much it goes over. Okay, vertical on top, horizontal on the bottom. Now, look at the equation. I reproduced the equation. Check this out. I wish I could be you guys seeing this for the first time, but I can't relive the joy. This equation here. Rearrange it. Pause there for a minute. Do you understand what I just did in that step? By saying nothing, that doesn't help.
You change the size of the exit.
All I did was subtract or add 4x on both sides.
You guys see that?
The next thing I'm going to do is important. I'm going to divide. I'm solving for y. What I'm doing. I'm going to divide both sides of the equation by 3. Now I'm going to go on one step further here and break that fraction into 2 pieces. You don't usually do this way, but you're certainly allowed. One last step, clean up everything by 1. This is a phenomenal form to have this line in. Do you remember what I said the slope was? Look at it. You see that 4 thirds screaming. You guys happen to remember what the y-intercept was? All of it is looking you in the face. Right here, the number in front of the x, that's the slope. Over here. Y-intercept. All you have to do to get all that information is to solve for y. Take the original equation and rearrange it. Now, when I go to graph this, I'm going to use that as my example graph. I'm not sure how I want to say it, but that's the version that I'm going to use when I make my graph. So let me come over here to this. And this is the way I'm going to graph from now on. I see this -8 here as the y-intercept. So let me grab myself a thick thing. I think I do red there we are. That -8 is the first thing I'm going to attack. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, and I'll put my dot there. Now, the way you get a second point to graph is different because now you do this. Starting at this point right here, what was the slope again? It was 4 thirds. That means from this point, you're going to go up 1, 2, 3, 4, and then you're going to go to the right, 1, 2, 3. And those are your 2 points to graph if you want. You can do this all day long. I can take this and go 1, 2, 3, 4, 1, 2, 3. And if I want more points, I can just keep going. The more you do, the more accurate you'll be. 2, 3, 4, and then over 1, 2, 3. So I went up and then right, up and then right. And then let me grab my line. And now you can certainly see that's exactly the same line we had before. All right, so this is the beautiful form we're going to be looking at today. Everything we work with, we're going to try to do that to it. Okay, let's go ahead and take a 10-minute break there. If I wanted to extend this line and make it longer, say I want to go in that direction down there, so let me give myself some more space. Then I will simply, to get another point, I'll simply go down 2, 3, 4, and then to the left of 3. So you can generate them, and as long as you know how to go in reverse, you should be fine. So, and then I can, if I want to extend this line, I don't know how to click on it though. I can extend this to include that. The only thing is I court danger every time I change what I'm doing because this thing seems to jump at weird stages unless I get to a certain stretch and then it's flexible. So, like I said, well, if you guys can stay here, I really don't care where you go during the break, but we're taking a 10-minute break now. I think I'm doing fine about it. Oh, I know what it was. right. We're going to graph this in any way you choose. But you'll find that it's a lot easier to do if you do it, because I told you, solve for y. Slope in the y. So if you still want to make up a chart, you can do that, but I'm saying that you don't have to make up a chart. You can now use what I just told you about slope to rewrite the equation first and then graph immediately. Got for the slope. So you're not going to divide first. When you get access to the other side, what is the first thing you're going to do? Oh. Why? That means get y by itself. If you get y by itself, what's the first thing you would do when you take the x stuff and get it to the other side? So if you subtract 2x from both sides, you get this. Then what I would do is divide by -7. This little trick, it's not really a trick per se. It's remember, you're going to break these fractions up, so you're going to have -2x over -7, and then I'm going to have 21 over -7. So there's a lot of negatives to fix up here, but you do get 2 over 7 times x plus 3. What's the slope? There's my m. What's that thing? Y-intercept. That's all I need to know. So do you remember what I did first as far as going to graph this thing? What was the first thing I did? Put the y-intercept. So the y-intercept is at 3. Tell me how to get there. I'm starting at the center of the graph. How do I get to that? Up 3 units. 1, 2, 3, and I'll lay a point down there. Carefully. Okay. Are you guys good? Now that I have that point in place, what am I going to move? How am I going to move now? Up 2, because slope is 2/7, so I'm going to go up 2 units. And then I'm going to go to the right 7 units. 1, 2, 3, 4, 5, 6, 7. Now I may run out of room, but I'm going to try it again. 1, 2, 1, 2, 3, 4, 5, 6. It's over here in my drawing. But as was asked before, if I also go here, I can reverse myself. So go down 2 and then go to the left 7 units. extend the line in the opposite direction. Got it. Now, when I graph my lines, I do like to pick the farthest away points because everything else in the middle of those will line up if I get these 2 points. So your most accurate graphing can occur if you graph the farthest away points. So if I can get that one to connect, if I'm trying, it's trying to get on there. I got it. You guys with me? So what are those steps? Could you tell me the steps if I ask you right now? What are there's basically 3 steps. What are they? Solve for y. Solve for y is step 1. From that, then you're able to replay. Solving for y is this business. Now, once you've solved for y, you can easily see the slope and the y-intercept. And then all you got to do is use those to help you graph. It's much more efficient than just plugging in trying different points. In fact, when you get out of, so when you try to do programming, there will be in programming, doing that versus the slow version would be a lot less desirable. Yeah. Okay. That's all I'm saying. They're automatically found for you, by the way. This one here, when you graph the whole thing, that spot is 0 or 0, 3. But this spot is here. This is where it crosses the x-axis. I don't know its exact value. It's probably, sure it's over 7. So this would be the case for the graphing. Yep. This y-intercept would have been possible. So this is almost always the preferred method. It's very easy. Right now, the part that I know students are bogged down in is this solving for y. But the other method, in most cases, you have zeros, but then you could have, in bad cases, you could have something in those that are left over. So you might have to pick different points besides 0 and 0. So that is a complication at the beginning of that process. So the process has their complications, that's what I'm saying. You might like doing it, but I can tell you this, every question in your textbook for a while is going to be asking you questions about the slope and the y-intercept. So you gotta have for the dome. That's right. Exactly right. This trick, this too, I think students are bothered by this part, taking this and then breaking it apart like this. But it's something you've done for 100 times, and you're like, in fact, well, once I hold your thought, if I were to give you a fraction that was a over b plus c over b, you would have no problem putting it together. However, to take something that was perfectly good and to break it apart seems unnatural. But you can do it. This equation means you can find them. They are the same thing. That's one method. So what they're going to be doing is this. This method is what we were doing here. We have 2 ways the lines are used. Ax plus by equals c, or y equals underscore b. I got to remember that the people at home cannot see me when I write on these boards. So I need to do everything up here. Sometimes you'll be given it in this form. Sometimes you'll be given it in this form. This, of course, the one we're working on today, that's called the slope intercept form. Usually it's the easiest version to tell things with. Tell the slope just by looking at it. You can tell the y-intercept just by looking at it. This here, I think, is called the standard form. So no matter what, one way or another, you're going to be switching in and out of one form to the other, depending on. In practicality, in real practice, it should cover. I've always used something like this. Probably if you were computer programming, designing a game, to understand that the screen is like a big matrix. Do you understand that? Horizontal and vertical, just like we have here. So knowing how things go like this is important for people like that. I don't know what version that they use or what's more easy, but my guess is this second version, better version, X values to get Y values out. And in programming, having a function, a thing that allows you to input stuff and get stuff out is a desirable thing. In the other one, you have to plug in the number and then find the value of the other number. And from a computer programming standpoint, that's a more complicated thing to do. So which one's better? I don't know. It depends on your situation. But we seem to think that y equals mx plus b is almost the best version you can possibly have. Let's sketch another graph. I know the question that's in your mind right now. How did you get that? Take the first equation and solve it for y and see if you don't get it. All I did was solve for y immediately. At this stage in my life, I can do it by looking at it.